Hello and welcome to the stream. So this is yet another episode of me working on the Sudoku Solver. And if this is the first time you are joining, the idea is kind of to come up with a solver that works kind of like a human. Of course, you can solve Sudokus pretty easily. You can just chuck constraint solving at it and it will be very performant and it will work for, any type of Sudoku you can imagine. But I kind of want to end up with a solver that's also able to tell me how hard a particular puzzle is. And I actually want to use it for other purposes as well. So again, I'm trying to recreate what a human would do with when solving a Sudoku puzzle. We are quite far along in the project, so we do have a very simple backtracking solver, which is, again, the easy and simple solver. That one isn't very performant because it's a backtracking solver, so it needs to kind of try all the possibilities, which, for a Sudoku, there are many possibilities, of course. We also have already implemented some of the techniques to solving a Sudoku. So the current solver can actually solve some of the easier Sudokus, but it's getting stuck on hard Sudokus. Yesterday, I worked on mainly cleaning up the code base, integrating, which are these? This is AppWare, I think, and this one is Travis, a continuous integration. So now we can, always see if the project is building. Unfortunately, for whatever reason, the code coverage is not working. And that's actually one of the things I want to investigate today. And then after that, one thing that I would really like to end up having today is actually some sort of setup for benchmarking the solvers. And by benchmarking, I don't really mean benchmarking the performance, although I do care about that as well. But I really care about figuring out how good at solving our solvers are. So kind of the output I would like to get out of a benchmark would be, hey, for this particular Sudoku puzzle, there were 0 guesses used. So like no backtracking was used to solve the puzzle. And let's say all that was needed was just, these 4 simple rules, or, these 4 simple rules were not enough and, the solver had to use like some of the more advanced ones. So kind of already kind of getting a measure of a Sudoku puzzle kind of based on what the solver did to actually get to the solution. We will see if we will get to that. I definitely want to first fix the code coverage because this is really annoying me. Well, to be fair, I did copy paste the code from a different repository, so there's definitely a possibility that what I copied just doesn't work, although it did work for them. So yeah, I'm quite curious what the problem here is. So let's get into that right now. So I was looking at this, and they have an example repository where they basically have, after success, they generate the coverage report. I think we do it differently though. So let's see. In Travis. No, was that Travis? Yes, so this is Travis CI, yes. So our Travis, it has bunch of jobs, yes. But we don't have any like after. We have after script, yes, here. So we do that for Xcode and for Linux GCC. We don't do it for Clang, which, sure, that works. I mean, the thing is, this does look correct. It could be that we don't actually have the coverage information. Because here they also specify the file name. But to be fair, like in this code, they actually do like explicitly generate the coverage.info. I can always try this. Just like edit here to, at least get errors if something is wrong. Because it could definitely be that it's just like rejecting the, returning like 500 error or something. Although actually this is just downloading a bash script. So this is curious. I am not quite sure what, because again, so this I actually copied from Jason Turner. Yeah, so why did I close? Damn it. This thing, yes. And it's pretty much just like drag and drop copy. There's like nothing extra here that I did to the file. The thing is, I don't really see. It's possible that I managed to like misconfigure something somewhere, but I don't think there's like anything extra with coverage. Yeah, so there's like enable coverage boot through. Maybe this doesn't work. Let's see. Where is that actually located? Oops. It's not here. It's not here. Okay, it's in sanitizers. Coverage 0. Okay, let's try this locally. Like, what actually happens if I just... this is way too big. Let me... Let's just decrease it very slightly. So what was the command again? This one. So we go to here. Oops. So now if I do this, I'm getting very suspicious if it's actually running the tests. because, like, first of all, it's very fast, which is always suspicious. Okay, let's just try to break one of the tests and see. No, it is running the tests. Okay. So in that case, like the thing I'm unsure about is like where is it actually supposed to put the coverage? Because I don't really see. Hmm, oops. Ah, we don't even have coverage. Okay, that. Ah, that would explain a couple of things. Uh, so it's looking for GCDA files. Uh, yeah, we don't have those. Hmm, curious. So I guess we broke something when we integrated the build. Okay, let's have a look at this again. Is there oops, is there any mention of coverage anywhere? I guess I would have to just do this. So let's just clone this locally. No, I actually want the HTTPS because I don't want to enter any passwords. Right. So let's have a look. If we just grab this for coverage. Yeah, so it's fully contained within sanitizers. Hmm. I wonder, so if I do this here, let's see if it actually, oops, if it actually generates the coverage if I just run it in the example. Because if it does, then yeah, that does narrow the problem to something I did to the repo. Hmm. Okay. Hmm. It does generate the coverage files. So this is clearly something I did that's screwing it up. Okay, let's actually have a look at this file. Project warnings, project options. Okay, so I think what's actually happening is the way it knows it should do coverage is actually through the project options. But since I'm never attaching this to my test libraries, test binaries, I guess it just means that nothing ever happens. Which would, I mean, that would make sense. Oh, and that would also explain why I was not getting any warnings. Huh, okay. Okay, let's try that. So if I go back to my C line, right. So in my CMake file, so if I do this, let's see if this, okay, didn't explode. So that's a good first step. Build. Okay, now let's try the CMake again. Where the heck is it? Yes, this one. Okay. Let's just build it again. Ah, now we are getting warnings. This is looking promising. Well, unfortunately, we have warnings treated as errors, which kind of screws us here. Okay. Well, I don't want to deal with that as of right now. And yeah, I will need to fix these actually. But how can I do this? Um, oh shoot, what was the? Yes, let's make. Oops. All right. No warnings as errors. Oh, wait. But we want coverage. Where the heck is it? Oh yeah, coverage is on. Okay. Um, okay, now it. Okay, perfect. Things are actually. Oh geez, yesterday this was such a hassle, but now things are actually coming together, which makes me so happy. So let's try the JTest now. Ooh, and it works. Oh my god. This is amazing. Okay, perfect. Um, well, Yeah, I mean, this makes me super happy. So that this just literally means that what we need to do is come here and just add this to all the files. Uh, no, that needs to be in the target link. Okay, target link, right. Perfect. And then I guess this needs target link libraries. So cool. This. Right. And I guess this changes our priorities for today, because this means that now I'm getting warnings for all my files, which means I should clean up the warnings. Yep, it seems to work perfectly now. Excellent. Okay, so in that case, what I want to do is, yeah, build, will rebuild. Okay, I just want to get all the warnings. So yes, warning, conversion from unsigned in to short unsigned in may change value. So max is uint 8. Okay, this gets a little bit tricky because like this is a templated function. So like if we don't want to have warnings here, I guess I'm just realizing like this can even break because this is actually complaining about the assignment, and this 0 already should be the same type as t. Let's do it this way. Oh crap. How do I do this? Oh yes. So what I kind of want to avoid is to have static casts all over the place. So I kind of want to limit this to like one location. And this is kind of the only way I can think of to do it. But this actually needs to be in the header because it's template. Oh, this is a bit tricky to get it right. So I want to static cast it to t. Will this work? I'm not quite sure. And then the idea is that here we would do this. Left shift of negative value? But max is unsigned. This is curious. Like, why would it think that this is negative value? Left shift of negative value. Or is this warning that we are shifting a negative value? This is quite interesting. This is honestly the first time I have seen this. Um, okay, this is interesting. It gets promoted to int. Hmm. I mean, one way to fix it, what we could do is just give up on the templating of the square and just have 64-bit as always as a baseline. I mean, it will hurt performance for smaller Sudokus because we can fit up to like 16 by 16 Sudoku into Uint16. But yes, like since we are doing yeah, exactly, like Uint16 will get promoted to int, which is super annoying because then there's a bunch of undefined operations on top of that. Yeah, I guess we have to. I'm very much not happy about this, but I guess. Mm, yeah, okay. Okay. Let's simplify the code. And let's think about performance later. I mean, I don't even know what the impact on the performance will be, honestly. It might be nothing. Um, but yeah. Okay, sure. Well, let's do it. Oops. Uh, I guess let's just find where people are using this. I mean, we can always revisit this later. So it's not a, it's not a crazy change to just make it templated again. Uh, but yeah, the simpler it can be, the better. I should have just renamed this, but I think the refactoring would choke on it because Square already exists, so I think it would just get confused. But yes, let's just get rid of the templating for now. And work with unsigned 64-bit ints. The good thing about that is, like, while I do kind of expect that to cause worse performance, because, well, we kind of will not be able to fit enough data into the caches. It will simplify things significantly, because honestly, 64 by 64 Sudokus are anyway definitely the limit we can do. Pretty much no matter what I try to do. Like, I don't really foresee any type of solver being able to solve bigger Sudokus than 64 by 64. So, and I mean, like, anyway, like, it becomes kind of ridiculous. Like, why would you do that? Like, humans will not be able to solve 64 by 64 Sudokus already. So, like, 16 by 16 is already super hard to do. Depending on the, the complexity of the puzzle, of course, but inherently, I'm trying to make a solver that works like a human, so kind of supporting things that humans don't do is kind of silly. But yes, I'm definitely worried about the performance impact, but it might be nothing. We will see, and if we need to optimize things, we'll optimize things. The moment we come to that. But for now, I'll just make things simple. Okay. I think that's it. Let me just go back to this and let's try to search for usages again. No usages. Okay. So this goes away. Now, this template, I really need to learn the keyboard shortcuts for, like, this program better, because I'm really failing at using it properly. So that goes away. We had it here, yes. Okay. Okay. Yeah, a bit more clean up, but we are coming to the end of this. Right. Anything else that I'm missing? Oh, how did I miss this one? Oh, and this one. What the heck? uh, yeah, okay, let's see. Build failed. Yes, we still have some errors somewhere. Oh, no, because now we are referring to the 0 that we just deleted. Right. Okay, one thing I want to look up is integer literality. 64-bit. Yeah, okay. So how do we say... Can we... Okay. So what I'm trying to figure out is if I have an unsigned 64-bit int, is there like a literal that I can I'm not quite sure. No. They're just starting casting. It's annoying. But well, okay, then I guess I bring back the 0. Um, okay, let's see. Okay, this needs to be static. Sure. Okay, bunch of conversions. But did this one work? Wow, so many warnings. Wow. Okay, so this one would be 0. Let's just go around and replace this wherever we have the 0, 0. Okay, so this one. I guess for this one we should make a helper function because we use it all over the place. Yes. So let's make it here. So I mean, most of this we can actually make convex prime, just realizing. But well, let's play with that later. That's fine. Right. So this one, oops, this one will be for sure static. Let's call it single bit. Right. Single bit at position, right? And just return 1. So static cast. So this, let's make this like this, right? Okay. Now we should get way less warnings with this little abstraction. Right. I'm kind of ambivalent about the readability of this code right now. It's kind of, yeah, kind of moved from like a very neat explicit thing to a little bit more messy, but meh, guess not a big deal. Right. And this. Oh, so this should be also 0. Right. Okay. Okay, what else? Do we have anything? No, that should be fine for this. So I think now from the square, oh, it's still complaining about stuff. Oh, because now, so okay, so all of these I think should just take unit 8 because I mean we can support at most 64 bits, so obviously the number cannot be that high. There's like no way. Okay. Any more of unsigned? This here. Okay, actually, let's just search for. Okay. Count possible. Yes, there will be also unit 8. This as well. Oops. Yeah, all the for loops should be. What? Okay. All the for loops should be the same. Okay, now we don't have unsigned anymore. But I think now we will get a lot of complaints about from the calling sites because they now get conversions. Warning, conversion from int to uint. Right. Now this is a problem. Ooh, this is... I'm so tempted to just make everything in 64. I mean, it will make things easier. Yeah. Yeah. I'm not happy about this at all. But yes, let's do a cleanup later. It's kind of annoying that I don't have 64-bit literals that I can just use. Okay. Hmm. I mean, we will have exactly the same problem on the calling sites. Oh, how should I do this? Okay, let's just. I don't want the complexity of the backing types leaking into the user code. So because of that, um, yeah, I will just do this kind of nonsense. And now I will leave the max as uint 8. Right. So I want basically all the methods if that talk about number, it will be just unsigned. Inherently, that should be enough because like even 8-bit integers are good enough for us. And I want to really hide that the data is uint 64. So the user code doesn't see that at all. Right. Let's do that. So right now it will just single bit will just talk about the number, not anything more. Okay. And this will only talk about unsigned again, as I said. All right. Signed, unsigned. Yeah, because otherwise would be a nightmare to just keep the types right. Sure, this is fine. Okay, now this is tricky. So yeah, so this will get promoted to an int. So we instead want it to get promoted to uint64. Here we can cast it into unsigned, that's fine. Yes. Right. Okay. And again, this pretty much only works because we know that the value of max will be at most 64, which is a very low number that we can basically fit into anything. Okay, this is wrong now. Right. So max value static cast. And here we just static cast it down to, because we know this is okay. We should definitely write some asserts around. Well, we are making, again, it's an assumption, right? Like we are making an assumption in the interface that no one will initiate this with something larger that what can fit into uint8, which is, 255 at most. So if someone would be crazy and try to make like 264 by 260, 56, numbers. So if someone would try to make a, massive Sudoku, then obviously this will just explode. It will probably explode silently because, yeah, I don't think. Yeah, that's okay. That's okay. That's okay. That's okay. No. So some architectures, I actually don't remember if you can make that on Intel, but some architectures actually have like number overflow protection, where if your number overflows, well, although for unsigned, that's actually fully defined. So yeah, this would just do weird stuff, I think. But I remember I was working on an IRIX server at some point that had some really weird CPU. And that one had some very fancy stuff when it comes to like what, if you did weird crap in your code, it would actually crash the binary. Right. Is possible number +1. So wait, what? Because size t is, oh, but here we don't want size t. Here we actually want unsigned. Yes, because we are going up to max, so that should be the same type. Yes. Cool. Now we are in the main. not in the square anymore. Okay, so this is now without warnings. Good. Now the question is, do I want to... So last time I introduced these operators. That's one thing. Do we have anything else that we want to do? I mean, we could do intersect. That's one operation that still kind of makes sense to make an operand. Operator, not operand. What else? Set. Should this be just an assignment? Maybe. Maybe it should. Okay. I need a 5-minute break. But yes, I think I will clean up this interface a little bit more because I see some opportunities to clean it up and finish the Doxygen documentation. And I guess have a quick look at the... Yeah, quick look at this. Oh, we have bugs in here, and oh yeah, because I'm not like rebuilding everything. Okay, let's just rebuild everything then. Okay, it's still built. Let's just do full rebuild. Okay, that's still built, but there's a lot of warnings. Yeah. Okay. Yeah, I think I will actually today invest the time into cleaning this up, because now since we are integrated with the continuous integration, I think it's very tempting to actually by default make warnings be errors. I think that would be very nice actually. Okay, anyway, time for a 5-minute break. See you later. And I'm back from my short break. So, yes, okay. What we wanted to do is to finish cleaning this up. So let's see, what's it complaining here? Conversion, size type, unsigned in. Um, yeah, that is a bit annoying. I wonder. I haven't used asserts in a long while. Let's see. Ah, nice reference here. uh, but yes, okay. We can. Interesting. I guess we don't really need the messages, but that's definitely interesting. Okay, let's go back to Sea Lion. So, oops, not here. What I want to do is make sure that max value is below. So yes, less equal 64. Because then the bits are 0 to 63, which, you know, it's the number of bits basically. I wonder if I should. I mean, if I do this, right? I should technically silence the warnings. Oh, serious? Okay, I wasn't expecting this. This is a weird warning because, I mean, this is platform specific. Like the size of unsigned long doesn't necessarily have to be 64 bits. Yeah, I don't know. I don't know how I feel about this. Like, I kind of want to make the interface in such a way that I don't have to deal with this internal crap on the other side, but yeah, I think I will just disable this warning because this is not. Again, like, this is platform specific. Like, you don't know. I mean, you can figure it out what the size of your unsigned long is, right? But, like, yeah, no. And compile warnings. Cast a line, blah, blah, blah. Yeah, it's actually explicitly said. Why the heck would it be explicitly said? That's yeah, that's weird. I don't agree with the decision. Uh, okay, let's try again. Yeah, okay, now it's gone. Um, so what's the next thing you're complaining about? Oh, this thing. Okay, so this is a thing I wanted to fix for a while. Um, so we don't have, like, the way we access the data from the Sudoku puzzle is super awkward because we go through data which gives us the double vector, then yeah, it's super awkward. The tricky part is if you, like, basically if you want to expose double brackets, what this means is that the first brackets need to kind of return something that also has the, one bracket, like bracket operator implemented. um so you kind of need to have like a helper type that, like a view or some, but basically a view of your internal data that you just return. But of course, the tricky part is, like, it's not necessarily view because you might want to mutate through that. So it's kind of more like a span, I guess, but not really. It's quite weird. Uh, but I mean, we can do that. Like, it's not a big deal. Um, and yeah, there's a lot of CEST to unsigned int conversions, unfortunately. Which, I mean, this will keep happening because our loops just work like that. Although this one in particular actually should be just unsigned, not like, we should really only have size t when we actually have a size, and we should never really do that. So this actually needs a cleanup because this is, yeah, we are kind of being weird here. Now I guess the question is, like, what are my priorities? Okay, let's first finish up with the square. So I think, uh, yeah, okay. We don't want a default constructor for sure because we always need to know the maximum value. Like, there's no getting around that. Actually, what we should be able to do here is this. Basically, delegate constructor. That should work in C++17, I think. No? Yes. Okay. So, default copy constructor. I mean, we don't, like, move constructor for this class is very silly. It doesn't really do anything, but I mean, I guess we can explicitly make it the default one. That works. So, okay, so this is our actual constructor. So this one will construct a square with all possibilities present. Right. So those that make sense is 25, 36, 49, is it? Yes, and 64. Yeah, so it's like 9 by 9. Well, The blocks are 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, and 8 by 8. Even though it might be possible that some of these actually aren't feasible. I'm sure they are feasible if, you either relax or, well, play with, the Sudoku rules. Okay, so this one will be exactly the same. Okay. So now, is possible... Sure, this will not be an operator, so this will we just keep it. Number is available as a possibility. Count possible. Okay, this one we also don't want to have as an operator. Return the number of possibilities still present. Yeah. That was a very pointless copy paste. The number of possibilities. Then is set. Okay, sure, that can also can't be an operator. Let's say only a single possibility is present. Right. Then value, sure, again, this will not be an operator. Returns the set value. If not set, team. Right. Next. Okay. So this one, what do we call it? It's not the Sentinel. It's I guess the starting number to search from. I guess, yeah. Okay, I don't have a better description for this. And then return 0 if none other are possible. Next possibility otherwise, right? Reset. Okay. Resets the square to contain all possibilities. And this is the opposite. We should call this reset to empty. Where is this? Oh, no, I have this. Where is this actually used? Yeah, okay, let's just call it reset to empty because we have reset. Refactor, rename, and let's call it reset to empty. Right. Resets the square to contain 0 possibilities. Right. Okay, now we have our operands. We have already. Why do I keep saying operands? Operators. So we have already done those. Reset changes changed, right? Has intersection. Okay. Okay, I think this should move. Up here. Next to the set, right? Okay. Okay. Has intersection. Okay, so this again can't really be an operator. So, but I think I will make intersect an operator. Whether there is possibility intersection, right? One possibility, right, and false otherwise. Okay, a lot of writing. Okay, so I said I want this one to be an operator. Let's see where it's actually used. Oh, only one place. Okay. So this one, I think I will just make it and yeah. I mean, it kind like that does kind of describe what it is. So it will be. I will have two versions. So one of them will be square operator and equals square r, and the other one will be just this, which just returns a square like this. Right. Okay. So this one is exactly this, except we also return this. This one is const, and I need a square result from this, then result dot data r dot data and return result. Right. Right, and return this, this one. The intersection result, right. And, okay, so that's good. This can go away, but first we want to do this. So this is a pointer, so I need to do this. Okay, but it should work. This can go away now. And set, we will make an assignment operator. So we need, right, we need one for a number and one. Okay, the default assignment operator can just be default, that's fine. So this one we just want default. But the set will be operator equals unsigned number will be this, return this, right? But now we need to figure out where set is called. Okay. Oh, and one thing we will need to do is make sure the constructor is explicit, because technically the constructor can convert any unsigned into a Sudoku square, which we definitely don't want to happen just like randomly in the code. It's something we definitely would want to control closely. Right. Okay. I think that's all. Let's try again. Yeah, that should be all. Okay. And I'm missing the documentation for this. Right, and returns this. Okay. Let's see if this still compiles. It does. Does it still? Do all the tests still work? Oh, the tests are not compiling. Cool. That's some stuff to fix. Searches conversions. Conversions. Okay, so first of all, this needs to be explicit. And this needs to be explicit. So now, okay, now it's complaining about ambiguous calls because we are passing in things that it cannot explicitly match. And there's like converting an int into like unsigned, like heavier peak. You can do that multiple ways. Oh shoot, no, I don't want this. Right. Oh, and more of this crap, right? Okay, so this test now builds. It's sure. I mean, that's not really an error. It's why is this an error? Like this should be just like a warning or something. Like yes, you just overwritten your coverage profile, but like who cares? Weird. Right. Is that it? Yep. Okay, that also works, and this thing, right, and still works. Okay. So now do we have anything remaining? Oh, the debug print, right. I mean, we could just make it an O-stream operator because we are not, I mean, we don't have another one. Yeah, I'm kind of fond of that idea. And actually, what would be nice to have yes. Okay, let's do that. So, std O-stream operator std O-stream like this. And yes, this is a const method. So then this is exactly the same, except we need to return the stream. And then what we want is the std string debug string. So sure, let's make it through string stream. Stream as yeah, basically this thing ends up being exactly the same. And then just return s dot string. Yes. So let's check where this is called. I think this should be on a code in main, I think. Yes. So what you want to do is s data ij like this. Okay. I think I'm missing some includes include string stream, right? No, it's s stream. Is the header? Yes. Okay. Build failed. No match to call operator. Okay, it doesn't like our method for whatever reason. So what exactly are you complaining about? that you cannot convert um, oh, because this cannot be right. I always forget. This cannot be an internal method. This has to be a free function because the order of the parameters is wrong. So this will be square s, right? So, too many s's. What do we call it? Let's call it r because it's the thing on the right side. Okay, r dot max, r is possible. Guess that's it. Yes. But then this needs to be friend. So, I just copy it. Right. Yeah, no, it's private. I just made you a friend of the class. What they're complaining about? Yeah, no, it's okay. Good. Still not happy. Oh, because now... Yes, okay, yeah. First time I'm actually breaking the linking here because everything else was implicitly inline because it's namespace Sudoku. Yeah, everything is implicitly inline because it's inside of the class, but now I finally have something that will not be inlined and it's failing linking, obviously. Right. Does it work now? Yes. Okay. So I would say this, I'm still missing the documentation, but other than that, I think the square is in a pretty good shape. I would still want to improve the testing coverage, but I think there are other things to concentrate on for now. So let's just add the documentation. Generate a debug string representing the possibilities in the square. Debug string formatted in and 9 are possibilities. Right. So that's the debug string, and I guess it doesn't really need a okay, something like this, I guess. And I guess we can optimize our headers at this point because we don't need these two here. They can move to here. And here we can just use the iOS forward. Okay, let's see. Does that work? Yes. Okay, let's just, yeah, sure. We don't need this to be inlined. That's kind of silly. So let's move it here as well. Now we should be happy with the includes and stuff missing and not missing. Yes, okay. So that's the square. Okay, this one I want to rename just to square test. Does that? Nope, that didn't. Yeah, I mean, there's no reason why it would rename these inherently like this. Yeah, but it's fine. Let's do that. Reload. Come on, reload. Why are you not? Oh yeah, now it reloaded. That should still build. That should still work. Okay, but wait, there was a. I have seen a thing rebuilt. What the heck are you complaining about? You have no reasons to complain. Okay, so this should be unsigned. Yes, this should also be unsigned. Definitely. It should also be unsigned. It should also be unsigned. Build, rebuild. Good. Okay, so we are at least getting no warnings from the test, even though the test is complete crap and doesn't really test much. But as I said, like let's not concentrate on that for now. Actually, what's the time? Okay. So we have the square. I really want to fix the stupid access to the squares of the puzzle in the Sudoku. So again, what we do now is we just do, where the heck is it? We just do data, we just returns the internal data, which is pretty bad. So what we kind of want to do is something like this, like I guess here we want size t, and then okay, I guess this should be yeah, okay, see, this is tricky because like effectively, yeah, it should be something like this, and then we should have like a Sudoku something, you know, like having basically a constant access to a row and having a non-constant access to a row. But that means I need to write Sudoku row and Sudoku row. One of the reasons why I actually want to do this is if we do this abstraction, we can actually change the data layout very easily, because like right now we have double nested vectors, which again is not an amazing data storage for this type of use case. Like at worst, we should have a one-dimensional vector that just has all the data. Because having nested vectors, like we are jumping around the memory like crazy, which is super hostile to caches. Again, that doesn't matter right now, but like I kind of want to move the code towards a place where things are actually pretty clean and we can kind of, when we actually end up in a situation where we want to optimize things, oh, we don't have to like, rewrite everything from scratch because suddenly, oh my God, like we cannot do the things we wanted to do because all the code is super wiry and hard to fix. So I kind of build abstractions that allow us to then say, oh, like I'm just ripping off the complete backend of this thing and replacing it, but none of the user code actually has to change. That's kind of the idea. Yeah. I mean, this will work. Like I need to write the Sudoku row and const Sudoku row, and those will have the bracket operators again. And basically, what they will get is like a span over the internal vector, I guess. I mean, we could even use std span, honestly. Like it's not like it doesn't really break anything. Like we are like if you think about it, this doesn't like we are not really using the vectors at all. Like we don't care about the dynamic reallocation. Like we can literally just basically get rid of, where the heck is it? Basically get rid of this thing and just make it, Sudoku. Well, now it's just a square pointer to square, and then just do data new square, and however many we want. And I mean, like again, nothing would change. And honestly, that might be the best. Like, there's absolutely no reason to drag vector into this. So then the question is, do I just want to return spans? Because I could do that. Okay, so let's see. If I go to CVP span. Oh shoot, this is C++20. I wonder, can I do C++20? Oh no, just dynamic extend is C++20. Yes, okay. No, so the rest of the stuff was already here. When it was span introduced? I don't remember. But anyway, like we can construct it. Let's see. We can construct it from iterators. But wait, is a span? Oh shoot. Span is only read only. There was the other thing, right? It was ranges, but that is 2020. Yeah. C++20, I mean. Yeah, that's unfortunate. I don't really want to jump to C++ 2020 yet. And in particular, like I do have the up-to-date Ubuntu now, but I don't think the compilers are there yet as far as C++ 20 goes. So probably not. That might not be a smart idea. So I guess I need to implement this my way. It shouldn't be too difficult though. I mean, so okay, let's think about it. So what if you want to have a Sudoku row, right? Then what we want here is square operator CEST index, which will basically be something like data index, return data index, yes, just very simple. And probably here we should have some sort of assert index less than len, something like this. And then, yeah, then we want the const version of this. Square operator CEST index const. It's a return data, exactly the same thing. So then, as private, we want to have data, which will, I guess this will just would be pointer to square, right? And then CEST len, I guess. So then how do we construct this? I guess we don't really want people constructing this like from scratch, so this will just have a private constructor. Okay, first of all, Sudoku, I guess this should be, making copies of this is okay, right? Like I just copy the pointer, I just copy the length. Fair enough, that doesn't really break anything as such. Wait a second. This is not in Sudoku namespace. Oh, it's not. Okay. Well, it should be. Okay, let's just put this one in there. This one in there, and then we can fix the rest later. So, okay, so default constructor we don't want. Copying this around, sure, go for it. Moving this around, sure, go for it. Yes. But then we want a special constructor, which will be Sudoku row from the actual data. CEST len, right? So data is data and len is len. And we want to make friend class Sudoku, because that's the only thing that can actually create this thing. Right. And I guess now Sudoku is not in the correct namespace. Yeah. So We kind of do need the const Sudoku row. I mean, the problem is I'm returning a new instance here, so like there's no way to, and it can be copied around, so there's like no way to prevent that from happening. So I kind of need a const Sudoku row as well. And what we want to make is that you can create a const Sudoku row from Sudoku row, but not vice versa. So you cannot like upgrade the const version to a full version. Yes, something like that. It's kind of the same as like having an iterator and a const iterator. That's kind of the same idea behind this. Yeah, okay. Well, let's do it. So that means that this needs to be namespace Sudoku, right? And this actually will be super simple. So this will be Sudoku row and with data dot data no data index dot data, and len will be data index dot size. Oops, like this, yes. Right, so we basically grab the vector that's responsible for the row, get its data, and then we get the size. Yes, okay. Oh. Right. But yes, this should be good. Of course, literally. Now for the const Sudoku row. So again, this will be basically the same thing as this. And I can literally just copy paste this. Except this will be, I guess this one also is a const point. I'm changing the wrong thing. Crap. Okay. So I want the const pointer to square here because yes, like there's no way to change the pointer once it's set. But here I want both of them to be const. So const Sudoku row square data blah blah, and yep. But we also want const Sudoku row from Sudoku row like this, and we also want the move constructor from Sudoku row, right? So this one will be, oh, and then we need the assignment operators the same way, basically. Okay, so this one will be data. Oh, okay. Oh, assignment operator will be tricky. Oh, because then Okay, we don't want the const here actually, I just realized. We just want a pointer to constant squares, but not the yeah. So, right. So here we want to do data is r.data and len is r.len. Yep, and exactly the same here because like for this one, there's no difference between moving and copying. Then this doesn't make sense. We only have the const operator. And this one should have this as a friend, yes. Okay. Okay. Okay, I think that's fine. And yep, that should work fine. Although I'm not sure if yeah, there's a const data access. Okay, I wasn't sure about that. Wait. I want to compile the big thing. Okay, so what are you complaining about? Is private within this? Yeah, okay, the namespaces are screwing this over. Okay, let's just move everything into Sudoku so to make it simpler on myself. Oh, that will. Oh shoot, this will require many changes. I'm just seeing that. Well, first of all, the test. Where the heck is it? Sudoku test. Yes. So this now needs to be in Sudoku. Yes. Oh, come on. Which, okay, that was like the easiest change. Then I guess that's fine. These can go away. Sure, that can stay as it is. But then the entire implementation needs to be in the namespace. Right. And then I guess main will complain that it cannot access anything. Okay, invalid conversion from const Sudoku square to Sudoku square. Oh, I have a wrong constructor for this thing somewhere. Where the heck is it? Const Sudoku row. This should be const. Yes. That's indeed correct. In member. Wait, what? Ah, yes, indeed. Missing semicolon. Primary exp. What the heck am I doing? Oh, it's replayed. What the? How that? Sometimes I just don't get anything. Okay, so this is in our main. So here I will need these qualifiers now, which isn't a big deal for the most part. Okay, so now it actually compiled. Right, so this stuff is working. Okay, rebuild everything. Let's see if things are... Okay, so there's some problem somewhere. So, wait a second, where's the actual error? So this is warning, 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 error. LLM is private. Oh, because this test now needs... As I said, I need to move everything into Sudoku namespace, which, I mean, that would have happened earlier or later anyway, so it's not massively big deal. I just need to do it. So, right. Okay. And the tests also need to move to the namespace. Okay. Let's see, does it compile now? Yeah, now we don't need all of these extra qualifiers. Because now everything is in the namespace. Yeah. Right. This is private within this context. Okay, that's strange. So whose method is that? Okay, so that's square. But square is in namespace Sudoku, no? It should be. Yes, it is. And I'm making the friends correctly. Okay, this is curious. So, oh wait, what the? Oh, I already was. Okay, I already was in the namespace Sudoku for some of the tests. Oh, I did that last time. I just remembered. Okay. Okay, okay. Still getting a lot of warnings, obviously. But honestly, that's not such a big deal. So let's actually try this. So if I get rid of the data usages and just use that instead, well, it does still compile, which is good. Wait, why is this int? Next, find empty. Oh, because this returns -1 potentially. Yeah, I mean, that will need a fix for sure at some point. Let's just try to get rid. Huh. This is using dot size. Well, I mean, we can always add the, but not to this one. We would basically need. Okay, let's just get rid of it where we can. Then I will need to go and clean up the rest. Because yes, like having the size method is a thing for sure. It is definitely a thing I will need to address at some point. Yes, okay, let's see. This is getting on my nerves so much that I actually want to fix this. Right, like this. So I want to do, basically what I want this to be is an unsigned at the end. So this I want like this, static cast unsigned. Wait a second. Why did this end up as an int? I mean, I guess it just gets promoted. Yeah. I mean, these are two characters. I'm doing difference. Oh, hey. Sorry, I'm not watching the stream, the chat so closely. I'm super concentrated on the code. Yeah, this is C++, a little bit different from Python. But yes, Python is definitely the language of today, for sure. Um, right. Okay. What is this one? If I just do this. Still not happy about it. Hmm. Yeah, some of these are a little bit awkward to fix. I think I will just have to add like the different variants to my square type. Basically, like all of these should take like all the unsigned variants, right? I mean, honestly, I just need to make it work for size T and unsigned, I guess. Um, Yeah, there's a bunch of these. Yeah. Okay, what's the time? Um, I wonder. I don't think I will be able to do the benchmark today. So that's a thing. So what did I want to do? I want to investigate the coverage reports. We actually done that. Clean up interfaces. Well, at least for Square we did it. Sudoku we kind of did it with the span types, but I didn't touch the benchmarks at all. Um, yeah, I kind of think like for most of these, I just need to be consistent. Like if I just use unsigned everywhere, like I mean, okay, so what I really need is actually to have, wait, these shouldn't be here anymore. Basically, what I need is unsigned size return static cast unsigned, right? And now I can kind of hide some of these things. So now this would be setup checkers size, right? Uh, that's fine. What the heck? Um, yes, okay, so that should be unsigned. Uh, yes. Well, like for many of these, I just need to make it consistent. So basically, we don't. At many places, we kind of leak the size T type in there, which shouldn't really be happening. What? Wait a second. I already have a size? Oh, I do. Oh, but that returns size T. Okay, so that kind of explains some things. Uh, right. Da, da, da. It's still okay. Like this will keep because this needs to be an unsigned. Yeah. Yeah, so it's this kind of inconsistency that like I have all over the place where result, yeah, like so again like this, yeah, yeah. I kind of screwed myself here with relying on just getting the size from the vectors, which I mean, okay, again, like the fix, the potential fix is pretty straightforward. I could just you know change the unsigned to size t, which I mean, sure. But I mean, I actually want to kind of keep this as it is to a degree, because data, yeah, like we really shouldn't be relying on the vectors. That's I don't want that in the code for the future. Oops. Yeah. Yeah, there's plenty of these converting CEST into unsigned, yes. Long, yeah, okay, so this set is, what is the set actually? So this should be a vector of unsigned. And yeah, I mean, this is kind of, this will keep bubbling through. Again, not CEST, unsigned. Yeah, there's like plenty of the locations where I kind of use the wrong thing. Yeah, unsigned. Yes, unsigned. Unsigned. Yeah, okay. So there's a lot of this for sure. Yeah, okay, now things broke because these are templates and they're sensitive to changing things like this. Let's just revert it for a bit. Okay, yeah. Let's just put it into a buildable state. Yeah, so all of this basically kind of will need a one pass cleanup where I move everything to unsigned. Okay, let's actually go here, and so this will actually be, I totally forgot what episode this is. I think this is episode number 8. Yes. So this is still the case. Okay, so what we need now is we need unsigned versus CEST cleanup. So we basically, what we want is, don't rely on vectors for the size. Actually, that's kind of it. Okay, all of that still remains as a to-do. We managed to clean up the square at least. So the next steps is clean up interface on block checker and Sudoku. Yeah, I think that kind of is it. Yeah, and hopefully next week we will be able to clean this up and switch warnings as errors on, which would be very neat now that we have continuous integration running. Yeah. Okay, before I finish, actually, what I want to do is, let's just try, where the heck is it? So we did try to fix the, what did we change here? Oh, this thing, yes. Right. So basically, I just want to see if the coverage now works, which, I mean, it should. What? What am I still missing? Uh, right. Okay, so we correctly pushed. Now, right, so this should rebuild and this thing should finally work once these are finished. So let's see. Build. Okay, so this is now building as well. Let's see. If this still doesn't work, then I'm really lost about the coverage because like now we should definitely be generating coverage files for sure. And if we are not, then I'm just very confused about what the heck is happening. Okay, things are happening. Oh, shoot. This is not building on Windows. Wait a second, it's complaining about really weird stuff. String is not a member of STD. Syntax errors. What? How? What? How? Where? Okay, square.h. STD string. Um. Oh. How did this happen? We do need to include string. What the hell is this? Like sometimes the compilation is weird. Like I would so wish if the like includes were stricter. I mean, hopefully we will get it with modules, but like I really hate it where it's like okay, like the ordering of your headers actually matters, and they have like macros that include different things. So sometimes suddenly like you things don't build because yeah, you don't have the explicitly the in the header that you were looking for. So this we can fix. Okay. Was it just this or was there some other error as well? Yeah, no, this really looks like it's just errors in. Is this just compiling for me locally? What the heck? Like, I mean, again, there's a lot of warnings, but it's compiling. weird. This is so weird. Okay. But I mean, this is exactly why I wanted the continuous integration, because it catches these weird things where like it builds on my machine for some extremely obscure reasons. Uh, okay. Okay. Okay, now I think we are back to the world of, yeah, okay. Bunch of warnings, but things are compiling. Okay, good. Shoot. Exited with, oh, the following warning is treated as an error. Man, I don't want to leave the project in a broken state. What about you? Are you also failing? Oh, jeez. Oh, man. Oh, man. Yeah, it's all broken. Fun stuff. Yeah, because the continuous integration is treating the errors as, I mean, the warnings as errors. Uh, well, I guess this is what regressions do. Yeah. Well, we made it worse. Which is good because it means we can make it better next week. Uh, yeah. I mean, at least we have warnings now, so it's a step in the right direction. It's a step down a cliff, but it's still the right direction. uh, okay. Yeah, I think I will just leave it in this semi-broken state. It definitely compiles if you turn off the warnings as errors, but yeah. Oh well. Thinking about popping in tomorrow just to fix it, but that will probably not happen. Okay, anyway, well, we are in this kind of broken state. Well, thanks for watching if you did. Hopefully next week we will come back and fix all this crap, so it actually compiles now even in the continuous integration. But at least, like, this was a problem before, we just didn't see the problem because it was, disabled, the checks were disabled. So now the checks are actually running and telling us that there is a problem, although problem here is kind of relative because again it's just mostly just size t versus unsigned, and again it's just my laziness is catching up with me now because yes, now I can no longer just get the size from the vectors. I actually need to have like a proper size method on all these things. So yes, thanks again for watching. Have a nice day, have a nice evening, good night, good morning, whichever applies, and see you next week.